we can actually measure inflation here and how it's done. How they do it is quite simple. They're going to track the prices of the same goods from each year to year. And you can actually do this as well too. You can make your own CPI. The government has a 300 base list that they use, so they take these 300 ones and they use them over and over. Okay. There's some advantages to this and there's some disadvantages. We'll talk about that one. And then what you do is you take a look. Normally, our base year is 1982. It's arbitrary. I don't know why they chose 1982, and they can move it probably in next year or so. They'll move it to 1992 once we get to 2022. Okay, but that's arbitrary. That's not a big deal for us. And then what we do is we look at the percent change from year to year. Okay, just like everything else we've done, we're always looking at the percent change. Okay, so just some facts. In 2016, the inflation rate was 2.1%. US prices have increased 98% since 1982. It's almost 100%. So prices have doubled. That should make sense. Okay. Inflation rate in Bolivia in 1985 was 50,000%. That's hyperinflation we talked about. That means a meal today would cost $12,525 a year later. And just so here we go. Let's build it. So this is going to be the most math that we have to do. And hopefully we're paying attention on this part right here, because if you follow the steps, it's easy. But if you don't, you'll get a little messed up. And we will have to calculate these, unfortunately. This is probably the most math we're going to do in the whole class ever. Okay. Okay. CPI. You can break this into different stuff. You can look at food, alcohol and cigarettes, clothing, housing. These are the big ones: transportation, health, communication, education. So you can compare them. Okay. For us, we're not going to take individual ones. We're going to take them all together. So we're just going to calculate one big one. It doesn't matter. But you look, you got education here at 5.6, food at 2.5, transportation is down 5.1%. Okay. So how do we make one? Okay, so here's the important part. One, we have to select a different number of goods and services. And I mean this not just derivatives of one. So for example, you can't take milk, yogurt, cottage cheese, beef. What else would work there? Yogurt, cottage cheese, milk. I said that one. Chocolate milk, right? Why don't those work? Because they're all come from cows. And if something happened to cows, your whole market would look skewed and you'd be like, this looks weird. Why are we having like a change rate of 80%? Okay, it doesn't feel like it. So you have to take different types of goods. You want gasoline, you want jeans, you want cheese. That's what you want to measure. Okay, cell phones, for example. You want to take all these different products so you can get it, because within there, the 300 that the government chooses, some might actually go down, but overall the prices might be going up. Okay, so just because one goes down doesn't mean, hey, we're not having inflation. Yeah, we're having inflation. It just might be that particular industry is going down. So you got to choose different ones. You got to track the same products. You can't switch. Okay. I think that's the big key right here. You need to have the same products. And just for reference, we will always set the base year at 100 or 1. You'll see what I mean here to make it work. Okay. Just base year is 100. Okay? Since we're looking at percent change, right? We need 100% is what we're starting with. So let's get started here. Okay, here's the formula. You need to put this down in your notes. CPI equals the price of the market basket over the price of the market basket in the base year. Then you will multiply that by 100. Okay? And that's going to give us our percentage. Now, if you want the percent change, we're just going to subtract the 100 off, but that's not a big deal. You guys already know how that works, okay? Because it's going to be over 100%. The reason why is something costs $2. The next year it costs 200. It's 100% of the price. It's the same because it can go down. And we'll see how all this works, okay? So let's say in 2000, the market basket for movies and pizza, movies is $6, pizza is $14, okay? We would just add those together. That means my base year is 100. Remember, that goes back to the notes. We always set the base year to 100. Okay. And then in 2015, we look at movies is $8 and pizza is 17. How would we calculate that? Well, we would just plug this in. Did I do it? Hopefully I did this. Okay. Our base is 100, right? So the price of in the base year, we'd put 20. What is our current one, which is 25? It'd be 25 divided by 20 times 100. Okay. That would give me an index of 125. What that tells me is from 2000 to 2015, prices increased by 25%. Okay. So we had an inflation rate of 25% between 2000 and 2015. That's actually kind of right. Okay. Now this is just a simple one. We just had movie and pizza. They're gonna make it a little more complex where we'll have to fill out a chart. So let me show you of how that works. Okay. That means the items that cost $100 in 2000 now cost $125 in 2015. So if you take a look, I gave you this one right here. So go ahead and pull that one up and let's do this one together. Let me get my calculator. Okay, since I just randomly made these numbers up and put everything together here because I want to show what I want to show. The numbers,
Mr. Madrid,
yeah.
For the example, is the 25 goes on the top or is it goes on the bottom?
25 goes on the top.
Oh, so it's 1.25.
1.25, yeah, times 100 will get you 125. That is correct.
Okay, thank you.
Yeah. Okay, got my calculator. Okay. On the test, by the way, these numbers will be a lot easier than the ones that we do here. Because you can't use a calculator. So the numbers always work out to nice whole numbers. But I think when I put this together, it didn't come out nice. And I apologize for that. Okay, so take a look. Nobody just buys one movie and one pizza for a whole year. So let's make it slightly more complicated. And we have 3 products here. Okay, here's the quantities that we bought. Now, maybe we buy more in year 2 and year 3, but we have to keep the same quantity. So we just move everything back to 30 and measure it from there. Okay, all you quite simply do is take 30 times 5, which is 150. 40 times 6, which is what, 240? And 60 times 150, I think that is going to be 90. Okay, so that's our total spending right there. Add these together, 150 plus 240 is what, 390? 390 plus 90 is 480. Double check that. Yeah, I don't want to make mistakes. 480. Okay, so that's pretty good. We got our calculations there. Now we just need to finish off the rest here. We do the same thing. You're going to take 30 times 7 now, which is 210. 40 times 5, which is 200. And 60 times 2, which is 120, which puts us at 530. Okay, so I did this on purpose because I want to highlight khaki pants right here. Or if you're from Canada, it's kahiki pants. But here we go. Look at how the pants dropped from 240 down to 200. But overall, look at our spending is up. I can already see we're going to have some inflation in this group right here. Even though pants goes down, khaki pants, overall our spending goes up, okay? Now let's keep continuing here. Let's just fill out the whole chart since we're here. 3 times 9 is 270. 40 times 4, that's dropping even more, which drops us down to 160. And 6 times 250, we got to increase that by another 30. There's 150. Add those all together. I don't feel like thinking. 580. Okay, so that's how we fill out the chart. Now, depending the percent change. So let's say we want to see from base year to year one. So we're going base, sorry, I'm working with the mouse here, to year one. How will we do that? Okay, so our base year we put on the bottom. That's going to be 480. Our year one, we're going to put at the top, 530. And multiply that by 100. Okay, so if we did that, 530 divided by 480 times 100, this is where our numbers come up ugly. Okay, roughly, I'm gonna round here. Do this one. I'll round it. Is about 110. Okay, 110. 110.4. 1/6 to the infinite, if we're going to be exact, but 110. So what is the percent change from base year to year one? Well, if I take this number, I just subtract out the 100, that gives me the percent change. That is 10%. So prices increase from the base year to year one by 10%. We could do base year to year two. Okay, so we just do take the same thing. 480 goes on the bottom. 580 goes on top. Multiply that by 100. So what do we get? Times 100. Looks like it's going to be, again, I should round this here, so I will round it. That was ugly. Let's just say 121. Okay, that means from base year to year two, prices increased. Let's see if I can show this from here to here. Prices increased by 21%. Okay, so from the base year to year two, prices increased by 21%. But we don't have to stop there. We can measure however we want to, okay? What if I want to go from year one to year two? It should be less than 21%. Okay, you just got to change at this point. Since we're going to year two, we can still plug in the 580 on top, but notice I'm using a different base in this case. Don't use 480 anymore. Use the 530 because that's what I'm measuring. I went from year one to year two. My year one now becomes my base year. So put the 530 down there. Times 100. And what is that roughly equivalent to? So about 4.4 109. Okay, subtract that 100 out. That means from year one to year two, prices increased by 9%. Okay. Sometimes it might be negative, okay? It could be negative as well too. Let's say we want to go from year two to year one, okay? So I need to reverse these numbers here. So now 530 goes on the top because I'm starting with year two. That becomes my base year. That's going to be 580. And we should get a lower percentage here. We're actually, if we subtract it out, we'll get a negative number. You see what I mean here in a minute. 530 divided by 580, okay, times 100, right? That leaves me with an equivalent of 91, right? So that gives me my raw, but if I want to see the percent change from going from year two to year one, I subtract out that 100, and you should expect this. So roughly we get about, let me just go 91. Otherwise, I'm going to keep rounding here. That's going to be negative 9%. Prices decrease. I didn't even have to do the math there. I'm so stupid. It's right up there. Okay. Anyhow, because prices decrease because we're measuring this direction, guess what? Prices decreased by negative 9%. So that's what happens right there. Okay. So here's what I want you guys to do. Let's do this here. You need to practice this. I can do this all day and not have a problem, but you're going to have to do this for the test. And